I know there's like a 10-second delay or something. So it shows that I'm streaming in OBS, but on YouTube it doesn't show that I am. I've already been streaming for a full minute, 59 seconds. Correct, I put in the new key. Yeah, nothing's popping up.
So, it is 2 o'clock. I'll wait for a few more people to come in, but for the people who aren't here, how is the audio? Can you guys hear me okay? Can you see the whiteboard? Oh, okay, and everything else? Is there too much glare, or should I just keep talking and stuff? Or talking? Alright. So, as we're waiting for a few more people to go in, pretty much today's workshop will be in 2 parts, and that is because both myself and Hugo Romero kind of work together to kind of break up the workload for this. So I will be doing the first part, which is where I talk about what is object-oriented programming, talk about how that works and why it's classified like that, and then I will talk about how C++ works with it. And then Hugo Romero will take over the Python section, and hopefully after today and after you see those 2 streams, you should be able to fairly comfortably, like, at least read both languages, if not program in both of them fluently. Alright. Oh, thanks, Montana. Alright. So, let me see. How many people? 5 watching now. Yep. That'll be fine. So, we can wait a little bit. How is everybody doing? Quarantine treating everybody okay? I swear at this point I'm almost used to it, but still getting a little bit of cabin fever. Oh yeah, and then there's like I think a 30-second delay or something like that, so if I ever like ask something and then stand here awkwardly, that's probably why. I'm not ignoring you. Internet is just, or YouTube's just that way. Yeah, going great, nice. Okay, so might as well get started. So first thing, this is my loose plan for the introductory part of this workshop. I'm going to talk about what is object-oriented programming, and what are the objects that we're messing with, and how do we mess with them. So, object-oriented programming is effectively where you create a bunch of different packets of data or different objects, as you will. So these can be anything from characters to numbers to double precision numbers or what have you, and then you mess with them in like code, either by using loops to store them or using mathematics to manipulate the data in them. And one way you can think of it as if you write a regular sentence like, I am going to the store. You can think of it as like this. There's 2 objects in here, and you have I and store. And you can manipulate I by going to this object. So, and that's how object-oriented programming effectively works. You create a bunch of stuff, and to repeat myself, is just you can store them, change them, reclassify them however you want. So that is, in essence, what object-oriented is. Now, what objects are a vast variety of things. There's a lot of base-level objects that any programming language kind of has. You have like regular integers, which are just like the numbers like 7 through like infinity. You have double precision numbers, which are just like numbers with decimals and have like however many decimals you want. You can have characters, which are letters, and you can have strings, which are a string of characters. Pretty much, so you can have a lot of, these are some of the base level objects that you can use to manipulate. So say you were making a calculator, you can have it to where you have just integer numbers and you can add them together and stuff. So you can declare objects, classify them however you want, and then you can manipulate them in the code. That's how the objects works, and that's what objects are. They're just any bit of data that you have that can be classified and then like manipulated or changed. So how you manipulate these are actually something that's like very, very intuitive. So remember before on the previous example how I said I am going to the store? Like I am going, you're putting the I into the store. That's kind of like you're putting that character into another like list of something, like a bunch of things that are in the store. So there's a few ways that you can always manipulate objects. There's conditional statements, which is like if else. So if you're talking to somebody and you're like, okay, hey, I want you to do this, and if you can't do else, or like if I want you to do this one thing, if you can't do that, do this other thing. That's like if else. And if you can't do any of these, do this last thing as the last resort. That is the if else statement in a nutshell. It's like you look at what they can do or what like is quantifiable or like what the identifier is, and you can then execute sections of code based off of what that is. So if, else, if, and then else is how it's written in C++, and then in Python it's if, elif, else. So, and you can, so how they work is that you can have the if statement, and then in C++ you put the parameters in here, like if my x equals 7, I want you to do like this bit of code. And if x equals 6, do this bit, else do this bit. So we can think of it as this if statement is these ifs and else ifs. You can choose one of these, and then based off of what the parameters are, or based off of like what you're working with, you can execute sections of programming. For instance, like before on the example, like, hey, if you are over 21, or if you are under 18, you can't buy alcohol. If you are over 18, you can buy alcohol. Else, and if you are over 21, you can buy a gun. So, no, that's a horrible example. That's my bad. Pretty much how this works is like that else if thing is you can check and see like, okay, if this thing is true, do this, and then this last else always triggers if none of the above is true. So, hey, if you can't do anything up here, do this last statement. And that's how the conditional statements work. And so those are pretty much the basic logic statements, and you can do, then after this is loops. So loops, there are two types. There's for loops and while loops. For loops, you can kind of use it as a counter. So do this for X amount of times. While loops is while this is true, keep doing this one thing. So while loops can run forever, and for loops tend to be structured to where you runs for a certain amount of times. And that is how they're generally used. Now, since this is programming language and it's kind of like up to the user how they want to manipulate stuff, you can make a for loop that runs forever by just making like the endpoint never happen. So like I want you to run forward forever, like for infinite amount of time. You can have infinite amount of time, or you can have it to where I want you to run forward as long as as long as you have a light in front of you by 4 feet or something, and somebody has a flashlight in front of them, making it so that they always have a light in front of them 4 feet. So you can have them run forever like that, similar to a while loop. However, and for a while loop, you can have it to where, okay, while you are hungry, keep eating. So you can have somebody who is like cursed and is always hungry, so they would eat forever, or you can have somebody who's like, okay, I'm no longer hungry, this is false, and then I exit out of it. that's kind of how these two things work. For loops I use a lot for counters, or like I want to look through something like a certain amount of times. Like I only want to execute this bit of code 7 times. So I use a for loop for that. While loop I use mainly for if I want something to run like a main operating system or like a main driver, like okay, while they haven't pushed exit button, keep this program running, or keep asking them questions, or what have you. So that's kind of how they're both generally used. So those are the effectively the the main methods for like programming language. Those are how you can manipulate them. With math, you can add and subtract and stuff like that. You can do base numbers and everything else. But say you want to like have a database and stuff, and there's no like objects. Like, okay, I need to have this database, and each object needs to have all this stuff, and it's not a number, it's not a character. What can I do? And that's where things called classes come from. So classes are pretty much where if none of the base objects that are already in like the main library of your programming language, like if they aren't there, you can create your own object to manipulate. And I'll go into specifics when I go over to like the other screen, because attached to this video, there's 3 resources. One is a quick reference guide that myself and Hugo put together that you can kind of use to like quickly look up, okay, what is this? What is the syntax for this in C++? What is the syntax for this in Python? Syntax is pretty much how things are written. So that's how it's generally used there. And then I also have my C++ example program over there. But for now, all you need to know about classes is if there's not an object that already exists that you need, you can create your own object. You can specify what data is stored in it, and then you can say how it's changed, or maybe you can make like functions inside of it that can execute based off of how you like call that function. So that is overall, without getting in depth into C++ and Python, how like everything that is effectively programming languages. Oh wait, no, I'm so sorry, I'm all over the place. There's also like storage containers. So before when I said I am going to the store, you can think of store as this one place that holds a bunch of different people, if I'm a person. So we can do, or those things are called, well, there's a bunch of different types. There's vectors, there's lists. They're effectively used to store data. So what a vector is, what a list is you just have like a specific data type, like int a. This is how you would do it in Python. You would declare a list, and all you need to know is that list only holds integers, and you can have it hold like a set amount of integers. You can have all like 7 integers, and then that's it for the list. But the cool thing about lists is that you can make them multi-dimensional. So for people who are really interested in math, you can make this like a 2-dimensional array and list and stuff, or you can make it a 3-dimensional one if you're doing like math and crazy storage for like different matrices or for graphics and stuff like that. But yeah, so without getting too technical, because after this it would be diving into how it's actually written out and works in the code. And since C++ and Python, they have the same lists. They both have vectors, they both have integers, they both have classes, they both have all these main core objects. They are written slightly differently, and some of them function slightly differently. So that's why I'm like kind of keeping things general and not going into depth, because that comes in a little bit. So learning lots of things by yourself. Good job, Montana. Sorry. Yeah, I have the computer over there because I'm using the webcam on my laptop. So right now, you guys the text is just small enough to where I have to come close and look. But so that in essence, that is everything that there is to programming. There are objects you can manipulate. if that object that you want to manipulate doesn't exist, you can create your own object. And you can store your objects, change them, do whatever you want using lists and vectors or what have you. And then how you manipulate them is conditional statements, basic mathematics, and like while loops or like loops that you can use to like execute certain commands over and over. That is overall the same concept that applies to every object-oriented programming language. That applies to C++, Java, and Python. So that is this first section. Does anybody have any questions about everything? I know I was all over the place because I kept remembering some sections that I forgot to leave out right here. But does anybody have anything that they want clarified or elaborated on while I take a sip of coffee as if I need it? Alright. Hello, people. How are you? Alright. So, let me see if I can draw this better while I'm waiting for some responses. All of them have that you can manipulate. You can either store you can manipulate them with loops. You can So if my explanation was a little bit all over the place, hello Kingdom Lover. Hello. So you will always have objects. If it doesn't exist in the current programming language, you can effectively create your own with classes. You can always store the object in the vector, list, array, or what have you, any kind of stored data type. Or you can manipulate these objects via loops and conditional statements. You can also use these loops and conditional statements to store those objects in said data structures, or you can use these loops and conditional statements to look at all those elements in those data structures and then like manipulate them that way as well. So hopefully that kind of helps clarify that. I know I was all over the place earlier. So here we go. Now I'll go over to my other screen and show you guys I'll talk about the resources that we have right here. So one of the things Hugo and I made was this reference guide. So if you already know C++ and like I already know in C++, okay, I know how to create an object. Here is the syntax you need for creating that object and in C++ and in Python. So here's an example of an integer, double. Bool is like true or false, and string. This is how you can like actually get the inputs from the terminal. So terminal is that one like black screen where you can type in like an input and then input data into a program or prompt the user to input something. This is how you would do that in both C++ and Python. I also included the library because C++ needs you to include a library at the top. All the library is it's just a list of a bunch of different classes and functions that you can then incorporate into your own program from another file. So you can create all these like cool bits of code and everything, and then say you want to use them over and over again, you can use them later on. In fact, in Hugo's section, he broke his code up where I kind of have all of mine in one file. He broke his up to where all of them are like in separate files, and then you just reference them into individual files. But yes, so and this again, so this is everything I'm talking about. Each of the loops, case statements, so switch statements, is effectively the same as if-else statements, except it's like structured differently, and that's effectively it. Some people prefer case statement because they like the look of it, and it's like, okay, this case 1, case 2, case 3, if it's this number, or that number, do this bit of code. Same thing for if-else statements. So there is that. Although case statements, yeah. And vectors, these are data storage types. And then this is classes. So with classes, we have like how you can create a class. You can also inherit properties from other classes. So that's an example of how you would structure inheritance and stuff. This is how you can make a constructor, which is pretty much when you declare a class, if you want to use it later in your program, how you would like specify that and structure it. And then logical operators. So like for some things, like for example, in a while loop, usually how a while loop works is that in here, you need, in order for this bit of code inside the while loop to run, you need this thing right in here to be true. So sometimes you can have it while a equals 7 right here, or a equals 6. So while a is 7 or 6, or is it right? Oh, my bad. Okay, that's the or in C++. So while a equals 7 or 6, then this bit of code runs. So you can have effectively multiple conditions up in your parameters for different loops in different sections. But yeah, that's effectively it. Main part of this workshop, it wasn't necessarily meant to be teaching how to program, because there are 2 college classes dedicated towards that. This is meant to be a general overview of kind of what are the aspects of all object-oriented programming languages, and then main part are these resources. So right here what I'm showing you is a resource guide, and over on, hold on, come on. Oh, my mouse is over there. I was looking at the wrong screen for my mouse. Here is the C++ program. This is the example I made, example program that I made. So here is a fully functional program that if you run it, all it does is it prompts the user. Hold on, I need to bring this. Nope. I need to bring this over here. Here's the terminal. It prompts the user on if they're inputting a worker, person, or if they want to exit the program. So say I want worker, name, Andrew, age, 22, students, and then it prompts you again. And you can keep inputting. It's effectively a database. You can keep inputting a worker, person. A worker has a bunch of parameters. Has like the age, occupation, name. If I did a person, all that has is Bob, and all that has is their name and age. And then if I want to exit, eggs, or say I have a typo there, I don't have a valid input, and if I want to exit, you exit the program. So that is all this example does. That is all Hugo's example should do. And walking through it, I kind of broke up each section on how they work. So right here, this is how you can include libraries. So include pc.h. This is a standard for Visual Studio, so this is Visual Studio's way of like, okay, include all of the base level libraries for C++ for this program. So without pc.h, it may not import like certain. I think it should still have like integer and double, but it may not have like the proper form of like string or vectors or what have you, or string vectors, arrays. I mean, and IOStream right here. You can look at it at the reference guide. This is how you can include the library for having that terminal input, like I was showing before. And vectors and strings, these are the two objects to where there is a base level in any standard library. However, that base level does have some capabilities that are not really effective in my opinion. So there's another, like, if you like include the main string library and vector library, you get a lot more functions and functionality than you would with this standard namespace. And this right here is declaring default library of what you're using. So, first thing we go into is classes. So here is an example of creating an entire class person. Here is the default. Here is a constructor where I can like create. Okay, what kind of data does this person store? And here is an accessor functions. All accessors do is it asks your program to look at that bit of data that's stored in your class. And then mutator makes it to where you can change the data that is stored in your class. And then in private, you just have all the data that's like kind of stored in this custom class object that you have. And then down here, we have an example of inheritance. So if I wanted to create a worker class that inherits all of the public functions from person, this is how you would write that function. So you could have a worker inheriting everything from the person for the constructor, and then all I would add is just an accessor for getting like the new data object for occupation, and then a mutator for that occupation. But I don't need to have all those previous functions because the worker inherited all of those from person. That's the beauty of inheritance. And then down here are examples of functions. So all functions are say you have a section of code that is like some complicated mathematical formula that is like 10 times long, or like 10 lines long. And you have a program that needs to run those 10 lines like 15 times throughout your entire program, or like 15 different times in different scenarios. So you can't really put it in a for loop and get them all done. What you can do is you can put it all into a function, and all a function does is it makes it to where if you call this in your main program, it runs whatever code is inside that function. So instead of writing those 10 lines, you can just write those 10 lines in the function and then call it in your main program, so you turn 10 lines into one effectively when you're writing your program. And it helps neaten things up, and it makes you have to do less work, which is why functions are great. And then here's the main function, here's the main program. We're declaring the variables to be used. So I have strings, I have an integer, and I have the vectors for storing like the worker and person. And then I ask the user, hey, what do you want to input? And I get the first answer they have. And then here is an example of how I usually use while loops. You notice how before during the runtime program, it stayed open until I had them press enter and exit. This is why it would stay open. So it was staying inside this while loop the entire time until I inputted exit. And so all that's in here is the conditional statement. So I'm checking to see, okay, if the answer is worker, I have them do what they need to do to input a worker. And after they're done inputting it, I create a new worker with that data, and I add it into the worker vector. So I add it into that storage. And then same thing for person. And if they didn't put in worker or person or exit, I have this else statement. So that's the not valid input. And at the bottom, after it's done interpreting their command or their input, it asks for another. So it's a very simple while loop that's a real-time database, or not real-time database, sorry. That's just prompting the user, getting an input, storing it, and keep on prompting them until they exit. And then at the end, after they exit out of that while loop, it displays the contents of what was inside of it. So feel free to use this one as a reference. Hugo will be streaming later today at 3 for his section of this workshop. So feel free to tune into that for the Python section, and for everything that I was kind of vague and confusing on, you can ask him about. Or like if you don't like the way I talk and everything else, you can ask him. So I really highly recommend tuning into that workshop. But again, so this reference right here, if I bring over the stream that I'm looking at, it is down right here. So the reference sheet is right here, and my example, I have it on my GitHub. So all a GitHub is just an online place where you can store code, and this is where it is stored on GitHub. So if you click that link, you would go here to my GitHub, and it's the only file here, C++ code, and here is all of the lines. So, and then same thing for Hugo. If you go to his, well, I'll let him elaborate on his, but his code is right there as well. So after today's workshop, if you want to use this later, I highly recommend at least getting or using this page, because this page will be very, very helpful, especially for people at CSUSB who have to take programming classes. I think there was some people that came from community college, learned the first programming class in Python, and then they came to our school, and they're like, oh, every class here is now in C++. I haven't worked with it before. You guys should be able to use this sheet and effectively convert your code from your Python that you normally know how to use into C++. Or if you're given a new lab assignment and you're like, I know how to do it in Python, I know the objects I need to use, I know how to structure them, here is the syntax in C++ that you need to know how to use. So that is the point of this reference guide, and the example programs are in the links as shown. So that is everything I have for today's workshop. I know it was a little bit quick and all over the place, but does anybody have any questions or anything that's I can elaborate on? I know I was all over the place, but yeah, I'll stay in here for about another 10 minutes, and Hugo's section should start up at 3 o'clock. So I will let him know that he could start at 3, and I'll hang around for another like 10 or 15 minutes in case anybody wants to ask anything. All right. So that is effectively everything. Here, I'm going to go back to this thing and make it so you guys are forced to see more of me, because I am egotistical and you guys now have to stare at me erasing the mess that was on the board. There we go. Alright. So, yeah, I'll stay here until 2:40 then. And I'll just erase the board real quick. In case anybody has anything they want to say, ask, or just say in general to me. My hair did get long, yeah. It got very, very long. That's why I need a barber or a haircut as soon as this quarantine is over. There we go. Yeah, no, my hair got stupid long. How's everybody's classes? Because I've been swamped with physics and math. CSE class isn't too bad, but you know, it is how it is. Too long. It's too long. Do you know about big O notation? Big O. I remember hearing about it in my third CSE class, but it's been 3 years and I forget exactly what it is. Big O. Big O isn't the efficiency of the program, is it? Big omega? Is this for physics or for programming? Or math? Because I think if it's for programming, all big O notation is just how efficient your program is. So it's like this program runs like on the efficiency of log. That is a horrible G. Log of n efficiency, or it goes like, okay, your program runs like n amount of times, so algorithm analysis. No, I haven't had to take that class because I am computer engineering. So I know physics and I know differential equations, but not O notation necessarily. Sorry. Good luck though. I believe in you. Yeah, I heard algorithm analysis is, well, it's a difficult class, but I heard that it's a lot of good stuff to learn, too. Part of me was tempted to try to take it just so I can learn what's in there and hopefully use it, but this is my last quarter, and I already have a full schedule, so I'm good getting my bachelor's in computer engineering, minoring in applied math and applied physics. That's a long enough title for me without extra classes. All right. Well, I'm going to end today's stream. So thank you everybody that showed up today, and I hope to see you guys in Hugo's stream. So thank you again for stopping by.